Okay, so this will be a quick video on, well, it's going to be an example of debugging some R code. So this code we see here was posted on Piazza, and the student was encountering an error. And I answered the post on Piazza, but I wanted to show how I found out what is wrong with this code. It's a very easy mistake for anyone to make that was made in this code, but it's not trivial to identify where it's happening. So I first want to talk about how I found this error, and then I want to go back and say how I would have potentially done this to reduce the chance of making this error. Okay, so I think that this is roughly starter code that I had provided. I think I would have had a space here, a space here. This, I don't know if I provided, but I'm glad this is here. If I didn't provide it, this will get us to look at the data, but we'll come back to that. Okay, so ignoring that down there, this is the starter code. And sort of by virtue of it being passed to you, it was valid code because it had to run itself on PrairieLearn. So in theory, you don't need to look at this code too closely, but I'm going to come back later and suggest that you should do that. In particular, we need to look at this variable here, or not variable, but this tibble here, which is the data we're going to be fitting a model to in a second. But now what I want to do is just run as is the student provided code. Okay, and we see a lot of things going on here. So we see this repeated warning message, unknown or uninitiated, what is that word? An uninitialized column type. And then when we go to calculate this thing here, we get a not a number, a NaN. Okay, so obviously there's something wrong here. And if you just kind of glance at the code, everything looks to be in order. So the next step is to run the code line by line. I'm going to space things out just a little bit here. Okay, so first, running this is akin to just, creating a function. And that seems to not trip any errors, but we haven't used the function yet, so this still could be the culprit. It looks like here we're writing another function, which again, in sort of creating the function, there's no error, but we haven't used it yet, so we don't know if there's any error. And now we're going to do this map to double thing. I'm going to put a space here because otherwise that would annoy me. That's a separate video on code style. I will do that. And we run this, and we see, okay, there's this, it keeps telling me, well, first of all, a big note here is that this is not an error. This is a warning. And the way we can tell that is, one, it says warning message. But two, not something we like, but it did run and store something in fold. So warnings are code that runs, but it's telling you, hey, maybe something was wrong. An error is something that just does not run. So we need to keep that distinction in mind. So we got a warning here, and so basically this line is where the code goes wrong for now. And then obviously we sort of don't care about this yet because the error happened here. But the trouble is, this line of code runs this function. And then something we might notice here is that the warning message happened 5 times. And if you think about what's happening when we run this, because we're doing 5-fold cross-validation, so we're running this function here with each of these 5 list elements. So essentially, an error happened each time we called this function with the different fold structure. So the error is somewhere in this code. Well, so what we need to do then is, instead of running it as a function, run it individually one time by ourselves. So instead of this index fold that the student wrote as the name of the argument to that function, I'm going to literally take the first fold and run everything that way. So I'm going to put that here and that here. So basically, this would be called stepping into the function, and now we're going to run it line by line and see which of these lines is the offending line. Okay. That's all good. That's all good. That's all good. That's all good. Oh, okay. So now we know that this is the offending line. So the next thing that we're going to do is say, well, the problem is either inside of this function, which we're running here, or what we're passing to the function is not what we expect. So, well, I'm just going to go ahead and say that this function is correct. Like we've seen functions that look like this a ton in this class. I think a lot of us at this point could look at this function and be like, yeah, that's right. Also, for all I know, this function was directly copy and pasted from somewhere that we've written it before. We're pretty certain in this function. So that means we need to check the arguments to the function. So this, and I'm going to start doing this a lot, we expect this to be a vector that stores the response variable within the validation set. And we expect this to be predicted values on the validation set. That looks good. It's a vector. It has the right factor levels and everything, so that seems okay. Uh-oh. So there's a problem here. And so something is wrong with this code here, which essentially says extract the type variable from the validation set. Well, let's have a look at the validation data set. Let's scroll up so we can see it. It's subtle, but the type variable has a capital T. This is a lowercase t. Annoying, right? So that's to say, if we go back to the original code, do a capital T there, now it works perfectly. So that's an easy mistake to make. All you have to do is accidentally not hold down shift when you're typing that code. So how can we maybe do this with a better chance of that not happening? So I'm going to suggest two things. Both are going to feel incredibly tedious, but in the long run, you'll encounter far fewer errors like this. Like, it's better to spend twice as much time writing the code than it is to spend 100 times debugging it and finding that tiny little error that compounded and made your life miserable trying to find it. So let's start back up here. So essentially, oh gosh, the two strategies that I'm going to say are, one, for every line of code that you write, state what you expect it to do, and then run it and see if that happened. And the other thing I'm going to suggest is always start specific and move to general. So what I mean by that is this code here is kind of generalized, meaning that it's repeating a process 5 times. Write it once without the function and without the map function and make sure that works, and then come back and put it into a function and run the map double thing. So let's sort of do that. I'm going to rewrite this code, but I'm going to do it in a very boring, tedious way. So to start, I would say don't even write any code. Go through the starter code and make sure you know what it does. So another thing I'm going to say here is that almost every line of our code, is this true? I think this is true. Every line of our code, you're running a function. That might not be true, but let's pretend that it is. So what does this line do? It runs the library function, and as input to it, we have this string. It's a vector of length 1, which holds a string per. So that's going to load the per package. And then same thing here, same thing here. And if I run those, it doesn't give me any error, so it's saying, oh, I'm going to clear this environment. And actually, I'm going to come over here to packages. And had I looked at this ahead of time, we can see that It works because the per package is now loaded. Okay, cool. Okay, so, and right now we see nothing in the environment because packages don't affect that. So the next thing we're going to do is set a seed. Again, there's not much you can do here to check that this actually happened, but we're running the function setSeed, and to it we're passing a vector of length 1, which stores this randomly generated number. Okay, cool. The next thing we're going to do is run this. So what this is going to do, and I'm stating my expectation here, is it's going to load the glass data frame or tibble from the package mlbench into our environment. So when I run this, note that in the upper right hand corner now, we now have this glass thing loaded into our environment. And here we see the different variables, including type, which is what we're interested in here. Okay, so the next thing that I'm doing is coercing. So right now, if I type glass, it is a data frame and it doesn't print as nicely, and I want it to be a tibble. So that's what this does. We see a difference there. Cool. And now I'm going to run it and store it. So we also see that in our environment now. Same exact thing, just different name. One's a tibble, one's a data frame. I probably should have just used the same name and overwrote it, but that's fine. Okay. Okay, so what does this do? And realistically, I wouldn't expect you to know what this does because we haven't even told you. And this wouldn't be something you would do in practice. But what it does is it creates a list where it has 5 elements, each one being a vector that stores indexes for rows of what will be a validation set in one of the folds. So running that, looking at the output, that seems to match what I just described. So a habit you're going to see me doing here is every time I run a line, I check what it did. I don't assume I know what it did. I don't pretend to know what it did. I check it because you need to know what the inputs of the function were and what the outputs of the function are. Okay, cool. Okay, so that was going through the starter code. Now to actual doing of things. Okay, so if we look at index fold 1. So, and let's also put our data set here. So this says I want these rows of this data set to be stored as a validation data set and the remaining rows to be an estimation data set. So what I'll do is I'll say, okay, so the validation data is the original data subsetted based on these things here. And you could check it first by running it without the assignment. That looks good. Or you could run it and then checked where you assigned it to. Note that it's now in our environment, and we can see here that it's 43 observations. That makes sense. It's a smaller portion. And then, so the other thing we want to do is create an estimation data set by doing not those rows. So we could check it without storing it, or we could store it and then check it. So now we have the estimation data set in our environment, and we see it has 171 observations. And we have the validation data set in our environment, and we see it has 43 observations. And so what do we say? 171 plus 43, and that is the number of rows, except I can't type. Oh gosh. The number of rows in the original data set. Okay, so cool. We've split up the data. Next, we wanted to fit a model to this data. I think we wanted to do our part. I'm going to cheat and look at this person's code. I just forgot what model I needed to fit. So like this. I'm going to put a space here, and I'm going to say data equals here. It doesn't change how the code runs. I just like the way it looks better. Again, more on that later. So I'm going to run that. It works. So I'm going to store that as model. So again, I'm being very tedious here, but we know like this code works. We have checked it along the way. Okay. Sorry. Next, I need to make predictions with that model on the validation data. So we'll do predict mod val. And that's not what I want. I don't want that. I want it to just tell me the classifications based on whichever of these probabilities is maximum. So like in this row here, I want it to return a 1 because this probability is the highest, I think. Yeah, it is. In row 2, I want it to return a 2 because this is highest. And it turns out that with trees and the predict function, if I do type equals class, I think that's what it does, but I don't know. Let's run it and check. Cool. So we'll call this val pred, store it. Cool. And then I want to calculate the accuracy. So I'm gonna do it differently. I'm just gonna directly calculate the accuracy in this specific instance. So what I want is the val predictions equal to val, and I'm going to use the autocomplete here. So I'm not even going to type. Oh God, it's annoying that the variable name is type. I'm not going to use my keyboard to enter the 4 characters to make this word. Instead, I'm going to pull this up by hitting tab, or it automatically comes up sometimes, and do that. So then there's no messing with it. It has to be a variable that existed. So that gives me whether or not things are equal, and if I do mean, that gives me the accuracy. Okay, so, and we can modify this and be like, okay, let's do full 2 instead, and okay, so now we want to generalize it. Okay, yeah, and just so again, this might not look like it's running a function, but technically there's in the background somewhere it's running a subsetting function. Here we're very clearly running a function. Here we're very clearly running a function. Here we're very clearly running a function. I should do another video just about what I would call my mental model for using R, which is that everything is a function running. So you need to worry about the inputs of that function, and if they're the right, say, data types, be it vector, list, data frame, tibble, model, object, whatever, and what are the expected outputs. We'll stick to what we're talking about now, but we'll talk about that later. Okay, so now I want to go about generalizing this. So the first thing I want to do is write a function, and we'll call the function calculate fold accuracy. And this is a function of some indexes to the data. And so roughly we want to put this code in there, and then instead of indexes like this, we'll put this placeholder for the name of the argument. Okay. So now, before running map or anything fancy like that, I'm just going to run this function. And I'm going to run this function with one of the elements of this list. So running it with this, we get something that looks like an accuracy, and so on and so forth. Okay, cool. So now we know it works. So now we need to do the business of generalizing it. So now I'm going to do map to those indexes, that function, right? Okay, and I see that it returns a list, but I'd prefer this to be a vector. So we'll do something like that, and we'll call this, no. Oh gosh, wait. Okay, we'll call this fold accuracies, that is the accuracy for each fold. Okay, and then we'll check what's stored in there. That looks good. And we'll take the mean of that and the standard deviation of that. Cool. So, yeah, that's kind of my process here. So I guess something so I guess again the two kind of takeaways here until I talk about a larger sort of more abstract mental model here is run each line of code individually, where you first ask yourself the question, what do I think is going to happen? And then you actually check what happened. And then 2, start specific and then go general. I think if you keep these 2 things in mind, you'll spend more time writing your code, but the probability of writing successful code that is accomplishing what you want to accomplish will be much higher. So it's a bit of a trade-off, but I think it's a really good habit to get into. This is legitimately how I write code. There are times where, like, maybe this line and this line after, oh gosh, nearly 15 years of writing R code, I'll skip it because I'm just like that confident that I know what it's doing. But that hubris will be the thing that comes back and bites me and leads to that one error that one day requires 4 hours of debugging to fix. So I think it's a really good idea to start getting into this habit of run each individual line of code, check the output of it. I think some of you that have interacted with me with office hours find that every time you show me code, that's what I do. Because again, even having written R code for almost 15 years, I don't have a magical ability to know with certainty what's going to happen when I see code. You have to run it. You have to check what happens. Okay, I probably just turned what could have been a 5-minute video into a 25-minute video, but as always, I don't have a good sign-off, so if you watched to the end, good job.